For the last several months, we have been talking and trying to get more information about this rare interstellar comet we've now come to know as 3I Atlas. And we've pulled in Harvard astronomer Avi Loeb many times, but today he's released two new papers about 3I Atlas, and he's joining us now to talk more about what he found. What's new?
Professor Avi Loeb has just released astonishing two new findings based on data from the SPHEREx Space Observatory that deepens the mystery to near impossible levels. Images taken between December 8th and 15th, 2025, revealed that the cloud of gas and dust surrounding the object, its coma, is not round like a typical comet. Instead, it is pear-shaped with a distinct elongation pointing directly toward the sun.
Based on data from the Hubble Space Telescope that was taken, there were a large number, 17 images taken between November 30th and December 27th by the Hubble Space Telescope, and they were shared publicly, and we were able to analyze them and notice that the jet coming from the object, there are two jets. There is a prominent one towards the sun and a smaller one away from the sun, and this jet structure seems to wobble over 7.2 hours. Basically wobbles around the rotation axis of the object, just like the light beam from when you look at the lighthouse, as it rotates, as it spins, the light beam is moving along a cone. And in the same way, the jets that are presumably launched from near the pole of the rotation axis are wobbling in the sky. And we can measure the rotation period of about 7.2 or 7.1 hours. And we also measure the same rotation period from the brightness variations of the object. So when the jets are moving around, the brightness of the object changes. And we notice exactly the same period. So this is a second paper where the brightness we monitored from a telescope on Earth. So the Hubble Space Telescope data and ground-based data seem to agree on the rotation period after perihelion, after the object passed near the sun. This is the first report on the rotation of 3I Atlas.
This confirms the existence of the anti-tail structure previously spotted by Hubble, but the SPHEREx data adds a new, baffling layer. Spectrophotometry shows that the signature for submicron dust particles, the tiny smoke-like grains usually found in comets, is completely absent. If this were a normal comet, solar radiation pressure would have blown these tiny particles back into a long tail trailing away from the sun. That tail does not exist. This absence forces a startling conclusion. The material shedding off 3I Atlas must be massive. We're talking about boulders and fragments larger than a millimeter, potentially up to 10 meters thick, which are too heavy to be pushed around by sunlight. This leads us to the new anomaly Loeb describes in his latest report. The gas plume around 3I Atlas is currently shining 100 times brighter than the object's solid nucleus. For a cloud of debris to reflect that much sunlight without containing fine dust, the total mass of the ejected material must be enormous. The sheer surface area required to create this glow using only large chunks of rock implies a mass loss rate that defies standard cometary physics. Furthermore, the chemical composition of this plume has shifted dramatically. Before its closest approach to the sun, perihelion, the object's spectrum was dominated by water ice absorption. Now, that signature has vanished, replaced by scattered light from organosilicaceous dust and a staggering surge in water gas emission, 20 times brighter than before. The object is effectively hemorrhaging 180 kilograms of water and carbon dioxide every single second, yet it refuses to form a standard tail. The timeline of our encounter with this object is punctuated by geometric coincidences that border on artificial. We are currently bracing for a critical observational window on January 22nd. On this date, Earth will pass directly between the Sun and 3I Atlas with a precision of less than 1 degree. This opposition surge will create a full illumination effect, amplified by a quantum mechanical phenomenon known as coherent backscattering. This surge in brightness is our best chance to analyze the bluish light scattering anomaly Loeb identified. The scattered sunlight from the object has shifted from a neutral ice spectrum to a distinct blue hue, typical of low albedo, dark dust. This observation on the 22nd is crucial for confirming if the boulders in the cloud are indeed dark, organic-rich fragments that are somehow resisting the solar wind while traveling against the flow of solar radiation. We must also reconsider the data mined from the Hubble Space Telescope, which provided the first concrete evidence of the object's structural weirdness. Hubble's 17 images from late 2025 revealed two distinct jets, a prominent one firing toward the sun and a smaller secondary one firing away. These jets are not stationary, they are wobbling. They oscillate around the object's rotation axis with a period of 7.2 hours, a heartbeat confirmed by ground-based telescopes monitoring the object's flickering brightness. But the scale of these jets is what keeps astronomers awake at night. The sunward-facing jet extends nearly 400,000 kilometers, roughly the distance from the Earth to the Moon. To see a coherent stream of material maintain its structure over such a vast distance, moving toward the star it is orbiting, is unprecedented. It behaves less like a passive cloud of debris and more like a directed exhaust plume or a stream of heavy ejecta that ignores the solar wind entirely. Adding to the list of impossible traits is the polarization of the light reflecting off 3I Atlas. Measurements taken months ago showed an extreme negative polarization that has never been seen in natural solar system bodies. Polarization measures how light waves are oriented as they bounce off a surface. High negative polarization typically implies a unique surface texture or composition, perhaps a metallic quality or a highly specific grain structure that doesn't occur naturally on icy comets. When you combine this with the absence of fine dust, the wobbling jets, the sunward orientation, and the massive water surge, the natural rock explanation begins to require more assumptions than the artificial one. Loeb warns that we are like cave dwellers who found a cell phone. We insist it is a shiny rock because rock is the only category our primitive database understands. Looking further ahead, the orbital path of 3I Atlas offers one final spine-tingling coincidence. On March 16, 2026, the object will make its closest approach to Jupiter. It will not just pass by random chance, it will thread the needle, passing exactly within the Hill radius, the specific distance where Jupiter's gravity becomes stronger than the Sun's gravity. This is a gravitationally significant region. If an artificial probe wanted to use Jupiter for a gravity assist or to deploy satellites into Jupiter's orbit, this is exactly where it would go. Loeb suggests we need to watch this encounter with every available asset, including the Juno spacecraft and the upcoming JUICE and Europa Clipper missions. If, after this flyby, we detect new, small satellites orbiting Jupiter that weren't there before, it would be the smoking gun for a Trojan horse scenario, a probe deploying daughter craft before exiting the system. Along with this, Avi Loeb has just confirmed a definitive and startling new metric regarding the interstellar object 3I Atlas. It is rotating with a precise period of 7.1 hours following its closest approach to the Sun. In a new analysis released hours ago, Loeb and his team utilized data from the Hubble Space Telescope and ground-based observatories in Italy to track the periodic wobbles of the object's jets. They found that the anti-sunward jet is precessing, wobbling around the rotation axis every 7.2 hours, while the object's brightness modulates every 7.136 hours. This creates a heartbeat variability, where the jets pump dust and gas into the surrounding coma like a heart pumping blood through veins. But the most disturbing detail is the alignment. The rotation axis of 3I Atlas is currently pointing within 20 degrees of the Sun itself. In the chaos of interstellar space, a random object has a probability of only 1.5 to 6% to possess such an alignment. This means 3I Atlas is not just tumbling randomly, it is spinning like a gyroscope with its pole locked onto the star it is orbiting, a behavior that defines the statistical likelihood of a natural rock. This 7.1-hour heartbeat represents a significant shift from previous data. Before the object reached perihelion on October 29, 2025, its rotation period was estimated at roughly 16 to 17 hours. The fact that the signal has essentially doubled in frequency suggests a dramatic transformation occurred during its fiery pass by the Sun. Loeb posits that the intense solar heating likely activated a second jet on the previously shadowed pole, or that the object is spun up due to the rocket effect of its massive outgassing. We're looking at a machine, or a rock behaving suspiciously like one, that has actively changed its operational state in response to our solar system's environment. This isn't a dead piece of ice melting in the void. It is a dynamic system responding to stimuli, firing jets that wobble with clockwork precision as it accelerates away from us. The mystery of what this heartbeat is pumping out is where the narrative shifts from strange to scientifically impossible. Newly analyzed images from the SPHEREx Space Observatory, taken in mid-December 2025, show that the gas plume around 3I Atlas is pear-shaped and elongated toward the Sun, confirming the anti-tail structure. However, the SPHEREx spectrophotometry data reveals a complete absence of sub-micron dust particles. A normal comet is a dirty snowball that releases fine, smoke-like dust, which solar pressure blows into a tail. 3I Atlas has none of this. Instead, it is surrounded by a cloud of what Loeb calls boulders, large fragments potentially millimeters to centimeters in size, or even larger. These chunks are too heavy for sunlight to push, which explains why there is no tail trailing behind it. We are seeing a swarm of heavy debris moving in formation with the nucleus, defying the standard physics of cometary disintegration. This debris cloud is generating a light signature that is equally baffling. The gas plume is currently shining 100 times brighter than the solid nucleus of the object itself. For a cloud of heavy boulders to reflect this much light, the mass loss rate must be astronomical. The object is hemorrhaging approximately 180 kilograms of water and carbon dioxide every second, a 20-fold increase from its pre-perihelion state. Yet the chemical signature has shifted. The water ice absorption lines have vanished, replaced by a spectrum dominated by organo-silicaceous dust and a blue color anomaly. Natural comets are usually reddish. 3I Atlas is scattering blue light, a signature often associated with Rayleigh scattering or specific artificial materials, further complicated by the extreme negative polarization of the light, a property never before seen in a solar system comet. The timing of these discoveries is critical because the universe is about to grant us a perfect view of the crime scene. On January 22, 2026, Earth will pass directly between the Sun and 3I Atlas, achieving an alignment precision of 0.69 degrees. This opposition surge will illuminate the object fully from our perspective, triggering a quantum mechanical effect known as coherent backscattering that will amplify its brightness. This is the moment truth arrives. If the object brightens significantly more than a natural rock should, it will confirm that the dust is indeed made of these anomalous, heavy blue scattering particles. This geometric coincidence is just one of many. The object lies within 5 degrees of the ecliptic plane, its rotation axis points at the Sun, and on March 16, 2026, it will pass exactly within the Hill sphere of Jupiter, the region where Jupiter's gravity dominates the Sun. A trajectory that threads the needle of our solar system's gravity wells with such precision feels less like a random toss of the cosmic dice and more like a calculated flight plan. While the scientific community scrambles to point every telescope larger than a meter at this target, the silence from the intelligence community looms large. When asked for records on 3I Atlas, the CIA issued a GLOMAR response. We can neither confirm nor deny the existence of such records. This classification suggests that the U.S. government is analyzing the object as a potential security threat or a black swan event. They are likely wary of the panic that could ensue if a technological origin were confirmed. However, Avi Loeb argues that we should not be afraid of the answer. He champions the idea that the Moon, with its lack of atmosphere and geological activity, acts as a museum for such interstellar artifacts. If 3I Atlas is a probe, it might not be the first to pass through. The lunar surface could be littered with the wreckage of previous visitors, waiting for the Artemis missions to uncover them. Loeb's critique of the current scientific approach is blistering. He notes that the SETI Institute scanned 3I Atlas for radio signals for a mere 5 hours before giving up. He equates this to a lonely person going on a date, checking their phone for 5 seconds, and declaring that nobody loves them. An interstellar probe that has drifted for thousands of years is unlikely to be blasting continuous radio waves in a format we understand exactly when we happen to be listening. We are aiming low by searching for microbes and radio beeps, while we should be aiming high by looking for physical artifacts and anomalous physics. As we approach the January 22nd window, the rotation period of 7.1 hours, the heartbeat of the jets, and the impossible dust cloud are all we have. But for Avi Loeb, they are enough to justify a one-way ticket to the stars if a craft were to land on his front lawn today. The evidence is mounting that 3I Atlas is not just a rock, and the next few weeks might finally prove it. The narrative of 3I-Atlas is a test of human curiosity versus human arrogance. We have an object that is undeniably weird, pear-shaped, dust-free, water-gushing, blue scattering, jet wobbling, and geometrically synchronized with the Earth, Sun, and Jupiter. The CIA is watching it in silence. The amateur astronomers are tracking it from their backyards, and Avi Loeb is shouting from the rooftops that we need to look up before it's too late. The data arriving in the next few weeks, specifically from the January 22nd alignment and the March Jupiter flyby, will likely determine whether this is just the strangest rock in history or the first page of a new chapter for humanity. As for Loeb, his stance is clear. If a spacecraft landed on his front lawn today and offered him a one-way ticket to follow this object to its source, he wouldn't hesitate. He would board the ship, leaving everything behind for the chance to know what lies in the dark between the stars.